Hi, I'm Paul Stringfellow. Welcome to another episode of Tech Interviews. So on this week's show, we're going to be looking at the area of IoT, and particularly the area of IoT security. IoT is obviously something that for many enterprises is becoming of growing interest, and they're starting to roll out increasing amounts of projects looking at the way that they can use sensors and data capture technologies to find new and interesting variants of their data and new ways to capture information that they can help to make more data-driven decisions. But how on earth do we effectively secure that? And so that raises an interesting topic, and one we're going to cover this week with my guest, Paul Clayson. Paul, how are you doing?
Great. Thank you for having us on. Great to be with you, Paul.
Yeah, well, great to. I almost feel like we've had this conversation before, Paul, before we get into it.
In the back of my mind is curious there, yes.
Yeah, it feels like deja vu. So for anybody wondering what we're talking about, myself and Paul recorded this show last week, and when I played it back, I found out that none of Paul's audio had been captured. So if anybody wanted a one-way conversation of me talking to myself, that's the show for you. We'll release that if there's demand. But this time, hopefully, we're going to capture everything because Paul had some really interesting areas that we're going to cover in this space. And I can say that now, knowing what some of the things that he's going to cover. So, but Paul, before we jump into the topic, why don't you introduce yourself? Tell us a little bit about who you are and what you do.
Sure. So I am the CEO of AgilePQ, which stands for Agile Post Quantum, which is an encryption security company based in Utah in the United States, here in what we call Silicon Slopes. A very large amount of tech companies here in Utah, and we're building a little company that is getting some great traction here.
Yeah, so that idea of post-quantum, we'll kind of dig into that a little bit later because I think it raises some really interesting questions around information security and encryption, full stop. So yeah, we'll kind of come to that. So obviously, you know, we talked about kind of the security space, and this is specifically around the area of IoT. So maybe, you know, to kind of set the scene a little bit, do you want to kind of share with us some of your experiences of kind of where the IoT market is right now, and maybe some of the particular security issues that we see with enterprises looking to deploy IoT solutions, IoT projects?
Sure. So every morning, all of us in our company here wake up knowing that there is a dramatic lack of security in the IoT world, and it's causing a massive loss of data and impacting the economic well-being of both entities, businesses, and individuals. And we know that the current legacy security that's on your smartphone and my smartphone, on our laptops and various other places, is incapable of securing these very small connected devices. In the Internet of Things, if you will. And there are at times insider threats as well that are causing problems here. And so we looked at that tremendous dearth of security, and the market estimates that well over 98% of all IoT devices do not have security at all, or have very inadequate security. We looked at that, and we went out and built a system that can impact that we can operate on the smallest of IoT devices. And this lack of security has begun to lead in our society and in our business systems and government systems around the world to a tremendous increase. I believe the statistics are that cybersecurity attacks increased 300% in 2019. That's due to, in large part, to all of these IoT devices being in the clear and not having any security at all.
So two things actually from that, Paul. You know, maybe we'll kind of delve into them separately. So I suppose my first question is, you know, because somebody may be listening to this and considering IoT projects, and they see these kind of small devices, small sensors that they may want to put on machinery or equipment or a vehicle or something similar to that, and they'll be looking at that thinking, well, where's a real security threat? How is this opening up, opening up pathways into my business, my organisation, my enterprise? How's this exposing my crucial business assets? So maybe if we start there, what are some of those realistic security threats that maybe people haven't considered with IoT?
Yeah, so maybe I'll start with an example. Maybe 3 years ago or so, there was what's called a DDoS attack, a distributed denial of service attack, perpetrated where over 300,000 small IoT devices were taken over by a bad actor, and then they harnessed through a computer program the collective power of those devices and attacked various entities in the United States. It ended up shutting down the internet all over the United States, and many of the big companies that are dealing in e-commerce and social media and so forth. That included Amazon, included Facebook, it included a lot of people. The estimated damage was $100 million for the very short period of time that they shut that internet down. So when you start to think about these IoT devices, well, let's say we have a Nest thermostat in a house. Let's say it's a Nest thermostat with an elderly couple, but they like being able to sit in their chair and change the temperature on that IoT device. But unknowingly, that IoT device could be taken over by a host of bad actors for a lot of reasons, and it could create a lot of problems for them. The DDoS attack is just one. What if it was taken over by a nation state so that they could know that they could have access to that device, and in the middle of a hot war, they could cause mass panic and all kinds of problems among consumers and the citizenry? What if you had a device on a manufacturing floor that was measuring a critical temperature for, let's say, the mixing of chemicals, and that was part of their IP, but somebody could access that IoT device and get the temperature and steal their IP? What if you had, even worse, a bad actor that could access that IoT device that was gauging a temperature in an oil and gas refinery plant, and they could send a signal to the server saying the temperature is exactly where it should be, but at the same time they're raising the temperature on a furnace, as an example, and they raised it to the point where there was a massive explosion. All of these kinds of things that I've just spoken to are not ethereal. They've all already happened. And there is a large number of news stories in the media out there about these kinds of things happening every single day. So to take this lightly and to not pay any attention to it is really very foolish in our world today. Yet companies and entities putting in place IoT devices have chosen to do that because perhaps they didn't know that there was a solution like ours available, or also because they take the tact of doing just good enough security. I once saw the example of the club that can fit on a steering wheel in a car to provide extra security so somebody couldn't steal the car. An organization did a study to find out how effective that was, and they found out the difference between having a club on the steering wheel and having no club on the steering wheel was 60 seconds. Professional thieves can get through that in 60 seconds. So, but people look at that and say that's good enough security, and that's kind of what's happening in the market today.
Yeah, and I think that idea actually of good enough security is an interesting proposition, because I think increasingly good enough security is perhaps not good enough, if that makes sense. But it's the idea where I think people have accepted kind of base level security, and I think increasingly, particularly when it comes to data, particularly the organisations now are being regulated to security needs to be better. You need to be showing, you need to be showing that you are doing not necessarily absolutely everything that you can do, but you are taking the most appropriate steps to secure your data, your infrastructure, your personal information. And I think that idea that I'm just doing kind of a base level and that will be enough, I think that maybe that perception's starting to change a little bit. And I thought the other thing actually that you said, Paul, that really concerned me was the idea that an old couple playing with their Nest thermostat. I mean, I love sitting there playing with the temperature of my thermostat. So what are you saying?
I, I have no comment on that. I don't want to get myself in trouble.
I mean, interestingly as well that it's so that idea of some of those kind of security infringements where we could be taking control of machinery, etc. I mean, is there also instances where an IoT device could be used as kind of a platform to get broader access to somebody's infrastructure, get access to key data, get access to other systems?
Yeah, absolutely. Yes. And I should have mentioned that one with the long list. People can get access to an IoT device and then ride the communication stream upstream to a server. So then they could get into the network system of the company that owns the IoT device. And there have been multiple cases of that where people ride the data stream upstream, do self-assembling code inside of a server, and then walk out the front door with a whole bunch of data that can include trade secrets, IP, it can include consumer records, customer records, all kinds of things. And that happens rather regularly. And what people are doing, is some people will put in place a username and a password and think that that's adequate security. And then they're surprised when people get through that. Typically, when an IoT device comes from a manufacturer, it is loaded with username and security. Username's typically admin, and the security password is typically admin, and so once they get through that, which is very easy, they're home free. Even if they change them, people can go out on the dark web today, and they can download a program, not legally, but they can download a program that will break usernames and passwords, and they get through them quite quickly. So usernames and passwords are a very minor security measure. If you take a username and a password, or authentication and authorization, as we talk about it, and you add another layer on top of that, perhaps of threat detection, and then you layer on top of that, the most important feature is encryption, where you're obfuscating all the data and nobody can ride that data. You can't attach to it. You can't go anywhere with that data. Then those start to become more effective security systems that have multiple layers.
So, Paul, that's really interesting. And kind of you talked there about, we kind of touched on this a little bit earlier about people are making decisions to maybe secure, to be good enough, or are making decisions that just usernames and passwords might be good enough. And you kind of touched on in your last answer there the idea of encryption. So for most of us who are dealing with data security on a day-to-day basis, we'll be looking at encryption as a key part of that kind of security posture, that security model. So when it comes to IoT devices, why are people not defaulting to the same kind of approach? Is it too difficult to do on an IoT device?
It is. In fact, so the smartphone that's on, or the encryption that is on your smartphone and mine, takes 3 megabytes to encrypt a single message, and then to decrypt it on the back end again. It takes 14 rounds of encryption in getting that done. It's the way the system is developed. Well, if you've got a very small IoT device, say like a Nest thermostat, or say like a temperature sensor in a manufacturing floor, those devices have a maximum of 100 kilobytes, usually less than 100 kilobytes in what's called a class 0 device, less than 100 kilobytes in total operating capacity, and less than 10 kilobytes in memory capacity. So if you're trying to use 3 megabytes or 3,000 kilobytes to encrypt a message, there's no way that it can be done on that small IoT device. It's impossible. So that creates a very difficult situation for the encryption, and when I talk about the security that works on your smartphone and mine, it's what's called IPsec, Internet Protocol Security. That includes AES encryption, and includes TLS, it includes actually over 100 different algorithms that have to do 14 rounds of encryption. So that's why it's so difficult. And that's, I mean, in our company, we came along and looked at that and said to send a message from a small IoT device to a server, we don't need over 100 algorithms. So as an example, in our product offering, our encryption code is 2.4 kilobytes total. And we do one encryption round and have two algorithms instead of over 100. I mean, the industry just has to rethink how we do this and put in place these kinds of tools that allow us to secure these devices and the communications on these devices.
Yeah, so it's interesting, and let's dig into a little bit about kind of what AgilePQ do, and we'll talk about the quantum stuff. I keep trailing the quantum stuff, so because quantum computing gets everybody's attention,
Sure.
and we'll kind of come to that in a moment. But so the idea of the approach that you guys are taking, because one of the things that I always like to look for when we have these kind of conversations is where is the industry heading. So there's clearly a problem with security when it comes to IoT devices. There's certainly something we need to think about and design into those solutions, but as you were just describing there's a problem with trying to implement what we would see as standard kind of protocols when it comes to securing data. So encryption being a really good example of that. Because actually the size of those devices is real small. Now you're kind of talking there then about the approach you're taking. So what is the approach that we're seeing? What are kind of the trends in the industry? Is it kind of going along the lines of what you guys are doing? Are you unique actually in doing what you're doing? Are you kind of first to market in this kind of space? And what kind, are we talking about a full, if we're going to kind of use your approach, are we looking at a full redesign of the way IoT works, or is this something we can retrospectively fit to IoT devices? How are people maybe listening to this thinking, I've got these IoT devices out there, I've never thought about securing them, I need to go away and secure them now. Is that something that I can do kind of retrospectively?
So there are standards, government standards that exist for encryption and for data in transit. That is that IPsec that I spoke about earlier, the security system. That has been in place for over 20 years. I think it's probably fair to say that computing platforms have changed a little in 20 years, but encryption hasn't. And encrypting and securing data in transit hasn't. So those security standards are in place. What's interesting is, as an example, in the United States federal government requires everybody to use that IPsec if you're going to do any business with the U.S. federal government, but they don't have a standard for devices that are now on the market and that the federal government is using that cannot use that IPsec. So we have obtained even federal government accounts in the United States without having that standard, and we think we'll be part of the standard going forward. We think that a new standard will be written around the kinds of things that we've done because the solution is so elegant. And our solution not only allows us to put this on new product introductions, but it does allow us to be able to flash our technology to an existing device. So a small piece of code in our solution does reside on the IoT device itself. And then other functions are done upstream, either on the gateway or in the server, to make that security for data in transit work. So we can do a firmware flash to secure existing devices. So we made this rather an easy, out-of-the-box solution. We built an SDK around our algorithms for encryption so that it's very easy to implement. We've built appropriate key servers so that you've got a key server that is extremely secure at both the front end to encrypt messages and at the back end to decrypt. We put together a full suite of tools to make this happen. So we're putting this into the marketplace and now, and we're getting a lot of traction because it is a unique solution, and we put together a full service, easy to use product.
So actually, just while he was talking there, and you kind of almost closed that description with easy to use product. I was kind of thinking as you're describing it that one of the things that's absolutely crucial when it comes to security is the simplicity of that security. You know, from a, if it's an end user security, it can't impinge too much on the end user's ability to kind of do their day job. You know, and I was thinking as you was talking there that when it comes to an IoT project, almost by their design, IoT projects tend to be at quite large scale because there's lots of these kind of sensors, devices, etc., kind of out in the field for an organization. So, you know, how easily scalable and manageable is that as an approach? You know, so if we wanted to kind of roll out an approach and roll out the kind of the AgilePQ approach, perhaps, you know, is that something that's easy for somebody to look at and say, yeah, actually it's easy to manage in the core, it's easy for me to deploy to all of my devices and to manage all of those devices? I mean, it sounds like you've probably already answered the question, but I'm going to ask it again anyway. So, you know, so.
Well, happy to answer it again. Absolutely. So we have signed a contract that puts for an organization that will put us on 300 million devices in the next 3 to 5 years, depending on how fast they roll them out. And you're exactly right. When these kinds of devices roll out, they're usually done in very, very large scale. So our technologies were developed as a software. We don't have any hardware component to what we do. We either do a firmware flash to the hardware, or we can integrate. And we have some projects going on right now where our technology will be embedded in chips before they go out. So you've got, in essence, a security system on a chip that is being sold into the IoT markets right away. So the ease of implementing and integrating that technology means everything when the market's moving as fast as it is, and the ability to scale means everything. We recently were asked to submit a proposal for a United States Department of Defense application that we had to show explicitly how we could scale to billions of devices within a short period of time. And so we submitted for that. So you're very perceptive, and you're exactly right. These kinds of solutions must be easy to use and highly scalable.
Well, I don't know about perceptive, or certainly I've been burnt by the security projects that are too difficult, and even the perception of them being difficult can kind of raise problems, because there's also a cost to that. You know, if a security project is difficult to roll out, there's a cost of implementation, and often security will kind of get sidestepped because people look at the bottom line without necessarily considering some of the things we spoke about at the beginning. You know, some of the real risks that come with, you know, using devices like this that start to open up gateways into managing devices. You know, often we will talk about kind of in the home where, you know, let's pick on the old folk playing with their Nest thermostat. You know, a bad actor gets hold of that Nest thermostat. The next thing we know, we're poaching old people in their homes. You know, it's something that, you know, if we allow that kind of easy thing to happen, it can open up to so many risks. And we talked before, and of course people won't forgive me if I don't now ask about the post-quantum element of the company name. You know, and I kind of know where this is going, because as we said before, we've recorded this once already. But this is the first time everybody else gets to hear it. Because one of the big issues, we've talked about encryption. We've talked about encryption as this kind of, kind of Rolls-Royce part of the way that we're going to secure our information, secure our data, secure our devices. But there is a concern, isn't there, in the security field about the idea of quantum computing, because we rely on encryption being very, very difficult for bad actors to crack. You know, so we talked about cracking usernames and passwords early on. Go onto the dark web. There's plenty of password crackers out there that can just brute force their way through some of that security. So we encrypt that data because actually there isn't that kind of approach necessarily to brute forcing modern encryption standards. But quantum computing potentially changes that. So for people who are wondering what on earth I'm going on about, do you kind of want to set the scene a little bit about the threat that quantum computing brings to encryption, not just in terms of IoT actually, but encryption in general?
Yeah, absolutely. So this is a serious problem. In fact, there's a lot of government legislation coming out around the world, and not only to force entities to use IoT encryption and IoT security to be able to stop unauthorized access and use of devices, but it's now starting to include post-quantum security. So we have these new computers coming. There already are companies that have hit quantum supremacy with some of their computers they've already developed. But these new computers don't operate the same way as the laptop that's on your desk and my desk. They don't use ones and zeros or binary code. They use qubits or quantum bits as their code, and it processes data very differently from a binary code. So think of it like a light switch. A binary code is on or off, a 1 or a 0. It's either on or off. A quantum computer is like having a dimmer switch, where you can start with very little light and you can go up to full light, but there are infinite number of possibilities in the middle. These quantum computers can process, instead of a linear manner of using ones and zeros, they can process multiple data at the same time. So it's done simultaneously. That allows them to process massive amounts of data very, very quickly. So if you've got an encryption code on your computer that has a finite threshold to it, it can't be broken by your laptop now if it's an AES 256, although AES 128 has already been broken multiple times and quite regularly. But AES 256 still can't be. But when a quantum computer hits the market, it can crunch through that massive amount of data doing simultaneous data calculations at once, and it will break through that AES 256. Now, we don't have a quantum computer on the market yet that can do that, but we've got countries around the world that are hacking other countries' databases and downloading their encrypted data and storing it, knowing that at some future time they're going to have a quantum computer that can break that, and then they'll be able to break that encryption and read the documents. It's a serious business. So in this legislation that's coming, governments and standards like are in place in Europe, and some coming in Asia and so forth, are starting to mandate that IoT security be in place, and that all security starting to be put in place now in dealing with governments must be post-quantum because they see that freight train coming. People in some places believe viable quantum computers that break encryption won't be around for 20 years, but there's a lot of people now who believe that threshold is coming down very rapidly, and many people, if not most people now, believe that we'll have a viable quantum computer to break encryption within about 5 years.
Well, I know, and I'm probably going back 2 years now, sat in an event with Microsoft where they were talking about some of their projects around where they're already building quantum computers. And like you said, they're not there. It's my next version of Windows 10 is not going to run on a quantum computer. But the fact that somebody like Microsoft in the data center space that they've got are already experimenting with that kind of thing, just goes to show that it's not 20 years away, is it? We're going to start seeing these kind of technologies come so much quicker. And again, something I already know the answer to, but obviously AgilePQ are post-quantum for a reason. This is already something that in the technology that you've deployed for trying to solve some of these problems around IoT, you've already built in a way of kind of protecting yourself against this kind of future threat. So do you want to talk a little bit about that? Just give people a kind of an overview of the way that you've gone about that.
Oh, sure, absolutely. In fact, since we had to kind of reimagine how you protect IoT devices, our brilliant engineers kind of set about solving both problems at once, of both the smallest devices plus post-quantum, and gosh, could we actually make the security on a small class 0 IoT device post-quantum? And they did that. So one of the ways that we did that, and there are multiple things that we do, but one of the ways that we did that is so the code on an IPsec, when you're encrypting a device, that code is so large, 3 megabytes to encrypt one device, but the keys that they use to do that are 32 bytes in size. The key to encode and to decode on the back end, it's 32 each. We were able to take so much of the operating code, we were able to take that down to such a small degree and take so much unnecessary stuff out of the code that we were able to dramatically increase the size of those keys. So 32 bytes for an IPsec, our keys are 288 bytes. So the total key space, the total amount of data that a computer would have to crunch through to break all possible combinations of a key is over 400 orders of magnitude larger than the keys that are used in an IPsec security system. That in itself is one way that we protect against quantum computers, because while an AES 256 system could be broken by quantum computer, the size of our key space cannot. So we just simply increased the key space so large that even quantum computers would take hundreds of years to be able to break that key space. So that's one of the ways that we came up with an elegant way, and we were able to do that by cutting out so much of the operating code on the encryption system itself that we could increase the size of those keys.
So, and I think elegant is such a good phrase, and you've used it a couple of times about kind of what you guys are doing. And I think it's a really interesting space that you're working in. And there's it sounds like some real innovation. I'm not pretending to be an expert in this space, but I know from my experience in other kind of data security methodologies and other kind of data security tactics and strategies that all of the things that you're talking about are real problems to be solved, and it sounds like you guys are making huge strides in solving some of those things.
I'm so proud of our crew, because every single day they suit up and show up and come to this office, and they are continually creating new innovations for the new world that we're in. And I just hang on by my fingernails for dear life with these guys, because they're really good.
Well, Paul, between us, we couldn't even get your audio on a podcast recording last week, so there's no hope for us. But two things I wanted to ask before we wrap up, because we're kind of coming to the end of our time here. So the first thing is something I always like to ask for. So for people listening to this show who are maybe considering IoT or have already begun to roll out an IoT project, one answer is, of course, come and speak to AgilePQ, but we'll come to that in a second. But if somebody's listening to this and they're somebody who's architecting this kind of solution, or they're involved strategically in the decisions around rolling out an IoT project inside an organization, is there a couple of tips that you would give them that they absolutely should have at the top of their list when it comes to considering the ways they're going to go and secure their IoT infrastructure?
Yeah, so there was a recent study done by a group out of Santa Fe, New Mexico in the United States called the Santa Fe Group, and they are a risk assessment and risk mitigation firm that looks at corporate risk and organizational risk. They determined that less than 25% of all companies who are deploying IoT devices know where all of their IoT devices are. And among that 25%, not many of the companies didn't know where all of them are, but knew where some of them are. And how does that happen? Well, you've got maybe a maintenance supervisor on a manufacturing floor who puts a vibration sensor on a motor to start monitoring for predictive maintenance. And they hook it up so that they can monitor what's happening, and they might put it on their own computer, but they never get it onto the corporate network system and registered as part of the system. If you don't know where your IoT devices are, how are you going to secure them? You can't. You can't know of the security that's happening on those. We built a threat detection engine as well that allows people to see what's happening on their devices as they and then stop it. So we created threat detection and threat mitigation. So the first thing that I would say is, if you're starting to build a system, number one, build in a way, either use a service like ours or use a service from someone else that you can see where all of the devices are. Are they on? Are they encrypted? Are they transmitting the data at the programmed intervals? Is it more or is it less? All of those kinds of things. Make sure you can see everything on that network. That's number one. Number two, start with security in mind. So just make sure that you know right up front at the very, very beginning, how are we going to secure these devices, and plan that in right at the beginning. It's so much easier to do it at the front end of these applications than it is. Even if we do a firmware flash off to somebody later on, that takes some work to get that done on behalf of people who are there. It's easy to use, but it's not without a work cycle to get it done. If you plan it right from the beginning, you'll do that very securely. And then I would say the third is make sure that you use components and building blocks of your IoT system that can operate in the most efficient manner and operate security and operate your native function of your device, so that all of that is built in right from the start. So all of this really kind of equates down to maybe one word, and that is security awareness. You just got to be aware that this is critical, that it's necessary, that the hacks are taking place every single day, and we've got to plan to stop those right from the beginning.
Yeah, and I think that plays perfectly into the kind of the security mantra of security by design, security by default. Think about these things, build it into your design, and make it the default state. Don't try and retrospectively deal with it. So I think there's some great examples, some great tips. And so, Paul, as we wrap up, I think everybody who's listening to this is probably as equally fascinated by the kind of the work you're doing and this topic, even if they're not delivering IoT inside of their own enterprise. I think that the whole security topic that this kind of touches on is one that's fascinating. So if people want to find out more about AgilePQ or find out more from you, what's a good way to come and kind of hunt you guys down online?
Oh, sure. You can go to our website at AgilePQ, AgilePQ.com, and you can find us there. We have a way to contact us on the website. If you want to, you can email me directly, and I'll put you in touch with our teams, and we can explore. My email is Clayson, Pclayson at AgilePQ.com, and we're pretty easy to find. I'd give out my mobile phone number, but given that you're in Europe, I might not want calls at 3 a.m, but I would take them. Believe me, I would. But we're pretty easy to find, and so we would welcome to answer any questions or engage with anybody, whether it be for sales or whether it be on participating in the thought process and in the thought leadership on how to protect these devices and what should be coming up in terms of either government legislation or corporate awareness.
Well, Paul, I think it's been a fascinating chat again, and hopefully everybody else gets to listen to it this time. So look, Paul, I'd say thanks for what you've covered. I'd say real interesting area, and I'm certainly going to be very interested to see kind of how AgilePQ continue to innovate and continue to evolve, because I think it's a very interesting space. You sound like a very interesting company to keep an eye on. So, but for now, Paul, thanks for being on Tech Interviews again, and look forward to having you on again to talk about something else in the near future. Thanks again, Paul.
It's really our pleasure, and we'll look forward to being with you again. Thank you, Paul.
I hope you enjoyed that. For show notes, pop over to techstringy.com. We'll also find all of our previous Tech Interviews episodes. And if you've got an idea for a show or would like to appear as a guest, then why not email me at podcast@techstringy.com. To catch the next episode of Tech Interviews, then why not subscribe? You can subscribe here on YouTube and, of course, in all good homes of podcasts, including Apple Podcasts, SoundCloud, Stitcher and Spotify. So until next time, thanks for watching.